like this and having a series of webinars. By the way, I've informed him about today's session, Anshu, and we hope that he'll join us.
Yeah.
But Ashutosh had pushed this idea last May, but thanks to COVID, we were not able to host an event like this. Now, of course, a lot of things have happened, and we've finally been able to organize this event. So,
Yeah.
is Manju ma'am on the
Yes, sir. Good evening to all of you.
ma'am, please take over the chair and please show us if your video is on.
My video. Okay, no. All right, here I am.
Yeah,
Hi,
there you
hi to
are.
everyone. Hi,
Hooray.
Anshu. So, I feel so privileged to have you here with us today,
Thank you so much.
and it'll be really nice for all of our students to listen to you and to interact with you. So I think without wasting much time, I'll hand over the mic to Dr. Sandeep Saini, who happens to be the moderator for this event. So over to you, Dr. Saini.
Sure. Thank you, ma'am. We have 58 participants now. Welcome, everyone. This is the first interactive session. Instead of calling it a talk, also, let us call it an interactive session with our alumni, Anshu Gupta. He is from 2005 batch, and right now he is the general manager ADAS of Continental AG. He was with us from 2005 to 2009, and after that he has completed his PhD from Germany. And today he is going to talk about automated driving and drive towards Vision Zero. So I welcome Anshu to start his session. It will be a brief session and there will be a larger portion for the questionnaire. So I request Anshu to take the lead now.
Okay. Thank you so much, Sandeep. Uh, First of all, thank you everyone for having me here. Uh, Especially as I think as the AP Singh sir mentioned, I was delivering a talk 1.5 years ago. Interesting story. I was delivering a talk on automotive radars in the European Microwave Conference. There I met Ashutosh Baheti, and he had this idea. And yes, it's good to interact with all of you. And thank you first of all to be here on a Saturday evening. I remember from my time it's not that easy, and thank you so much. And hopefully from the time when I passed out, I'm much more kilo X heavier, hopefully a bit more wiser. The main idea is to show you where the industry is heading and how can you contribute, and how can you be a part of this. And I would love to be in one of our lecture theaters. As I was mentioning, it's much more simpler to sneak it from the back. But yes, definitely would like to be there in person. But till then, I think this is the best solution. Uh, I will now just share my screen. All right. So please let me know when you see my presentation.
Yes, it is visible now.
Okay. So I think as Sandeep mentioned, I have been myself to a lot of industry talks in my times. To be honest, some were fantastically boring. So this time I have tried my best to keep it as interesting for you as possible and to keep it as short as possible so you have more time to discuss. Just give you an impression, where is because we are talking so much about autonomous driving. We are talking about assisted driving also. And if you know already in India, we have some solution with MG Gloucester and later in the future by Mahindra, which are in India, such features of assisted driving are coming up. Just want to let you know where the industry is and how you as a potential talent can contribute and what can you expect. All right, without further ado, first I would just let you know what is where I work for. I work for a business unit in Continental called ADAS, Advanced Driving Assistance Systems. And our mission is very simple. We want to make sensors. We want to make smart cars which can do fully automated driving. And this is a vision which we want to achieve in some time now. Why do we want to do this? And fully autonomous car makes life on the road safe for everybody else. We talked about Vision Zero. What is Vision Zero? For us, the Vision Zero is very simple: zero accidents, zero casualties, and zero fatalities, which means roads will be absolutely safe for everyone else. And as of now, I'm a department head, and I'm responsible for all the low cost radar which goes in the car across. So right now we have, in the past 3 years, we have put in more than 50 million radars on the road. So you can imagine this technology is everywhere now. If you go to Europe, if you go to America, if you go to Japan, now even in China, you will see cars that can do some sort of automation themselves. And I will tell you in the slides ahead what kind of automation is possible as of now, what is the roadmap for the future, and how we want to go there. This is again my motivation for daily work. I am not a good driver myself. I am scared of driving, and it's not that I've been scared of driving now. I've been scared of driving from the start onwards. So when I got this opportunity to contribute to this topic after my PhD, I was more than happy. As of now, imagine 1.35 million people lose their life every year in road accidents. It is the most dangerous everyday event which we do. So it is far more dangerous than flying, and very, very far more dangerous than taking by train. And get it right, it is far, far more dangerous than COVID also. So our motivation is very simple. We want to reduce this number as much as possible. And just to give you an impression, most of the deaths, which are in these big bubbles which you see, there are in Southeast Asia and Africa. And there's no surprise about that. If you see the amount of casualties which we have in India per person, casualties in India on the road is very, very high as compared to Europe, Mediterranean, even some parts of Africa also. Now, one part is assisted driving and making roads safer. Second part, as you talk about, is automated driving. There is a lot of discussion in the media, a lot of talks going around. What is the state of automated driving as of now in our country? Sorry, in the world. Sorry, not in our country. Right now, we have solutions like we have solutions from Google. We have solutions from Uber. We have solutions from other companies in which you can do some partial automation. What I mean by partial automation is that some parts of the road a car can drive, or and the vehicle can drive by itself without any driver. However, this technology is it's in an infancy as of now. So we are also working with this technology. We are also trying to understand how and why and in which scenarios this technology can be a part of the greater society. And in this sense, we have developed this small car or a minibus, whatever you call it. We call it Cube. This has a radar. This has a lot of continental sensors. What are the sensors? I will I'll talk to them in the future, in the later slides. But this is something which we have developed in Continental. And I'm very proud to say my department and my team, we were involved in developing the radar sensor for this car. And I'll show you what this means, at least. I'll show you this video. So I think me better than talking, then I think you can just look at the video. And this is so we have tested, just give an impression, we have already tested some around 10,000 hours with this small car of ours in the city of Frankfurt, which is very, very complex traffic. Just have a look what we have done, and you'll get an impression where the industry is heading. So this is the city of Frankfurt. The reason we chose Frankfurt is it is very complex, and also it is part of our autonomous driving headquarters. So this car, it's a very small, there's five, six people can sit. There is no driver, as you can see. It has a lot of sensors around, and it will drive automatically on small streets, on big streets, and it has a maximum speed of 35 kilometers per hour. So it senses the traffic around, it senses the pedestrians around, and you can hit a button inside saying, okay, that I want to stop. And it has some dedicated stops where it will stop it by itself. So you see now it can sense traffic lights, it can sense incoming. Also tested it on very small and very crowded roads within Frankfurt to see how good and how perceptive the algorithms are inside. This is a high-speed road within Frankfurt. And this is where we wanted to drive on this road because there's a lot of pedestrian traffic here, because pedestrian didn't do it in a very, very smooth way. So I've sat inside this car, and it really, the acceleration and the deceleration feels very, very smooth. It's very difficult it's easier to forget that is not being driven by a real driver. It is being driven by the algorithms inside. And the radar which is used inside, there's a long range radar which is range of 200 meters. The algorithm for this long range radar has been developed by my department, and I'm really very proud about that. And then we have a very good team which helps in doing this. So I just want to make sure you understand that autonomous driving is not very far away. I know it is not there in India, but we have a lot of R&D centers like Continental, like ours, where there are a lot of people who are working on these problems and finding innovative solutions to these problems. All right. So as I promised, I just want to show you what has happened in the past and where the industry is heading in the future. So till 2016, as you see, we have had a place where the market was heading towards assisted functions. What do you mean by assisted function? Assisted function means that a car can do some partial automation. So but a driver has to be active and has to keep the hands on the steering wheel and has to be actively watching the road. What do I mean by this? Example is emergency braking. Emergency braking means, let's say if you're driving on the road and a kid comes in front, right? And you are looking at a billboard of a new movie on the sides. What will happen is the car will sense that there is a pedestrian in front, will give you a warning. If you do not heed to the warning, then it will give you a buzzer to make sure that you are attentive. Even if you do not do that, then the car will start making a small brake by itself, decelerate slightly. And if the car thinks there is no way to protect the pedestrian but to make a full brake, the car will make a full brake, 1G brake. And let me tell you, in our lifetimes, it will be only very few instances where we experience 1G braking. 1G braking, the full force of the brake is applied to make sure that the pedestrian is saved. Second part is traffic jam assist. So this is already launched in China and in US, in Japan for sure. Now also in Argentina, both all these the functions for assisted driving. Traffic jam assist means that the car will follow the car in front in a traffic jam and can also make some lane change. So let's say if the car in front goes to the left and there is some space in between, the car will accelerate and try to catch up to the car in front. And if the car sees, okay, that there is a lane on the left which is empty, which you can go to, then car will automatically change the lane for you. Then we have simple functions like lane keep assist and lane change assist, which means, let's say if you're driving your car and you want to change the lane, right? If you want to overtake someone, what generally happens is we forget to see that there's someone coming from the back. And as soon as you change your lane, you might get a back collision. So there's a sensor, there's a radar, and there's a camera which looks at the back, which will warn when you want to change the lane. It will warn you, be careful, there's a car coming from the back. This is something which we have already achieved, And just to give you an impression, we have made a business of more than $2 billion till now in the past 2 years with selling these functions which are already available. So there are more than 1.5 crore cars in the world which have these functions already in them driving on the road right now. So it's a very good business opportunity. In future, what we see is we have to go towards from assisted to partial automation. What does partial automation mean? Partial automation means that at, for few cases, especially on highway, this is partial automation is what you have in Tesla also, their highway assist. And this is something which we have now launched with Mercedes. In the new Mercedes S-Class also have our highway assist. We call it Autobahn Chauffeur. Autobahn is just a German word for highway. So highway chauffeur. In that, what you can do is you can set a speed and you can take your hands off the wheel. However, you cannot take the eyes off the road, which means that the car will drive on a highway, will change lanes, will maneuver on the highway, but you, the driver, still has to be attentive. And the car can always request the driver to come back and take control when the car feels that the situation is not, the car cannot interpret. This was released this year, the last year, 2020, we released it for Mercedes. And finally, as you see here, we have highly autonomous driving, we have low speed chauffeur, we have parking pilot, and some sorts of high level of highway chauffeur. What I mean by this is here, what we see after 2025, we see a strong trend in the industry that you will go to a place where at least in some such certain such situations, you can take your hands off the steering wheel and you can even start reading a newspaper. So driver doesn't have to be always attentive. Very interesting concept for this is parking pilot, which means at least it's very difficult for me to park my cars in malls. Or if you take your car to Johari Bazaar and if you want to park your car in Johari Bazaar, it's no fun. Yeah? Imagine you can press a button and you can get out of the car. You can go there, eat your chaat, the car will go and park by itself. It can happen in mall, and if everything goes right, when you have a low speed chauffeur already activated, you can also do it in Johari Bazaar also. So this is where we see that trend will happen from 2025. However, for sure, we will not have all the solution by 2025, but the revenues which we see from here will start increasing. Good. Now, as I mentioned, actually it was there in the cube, and the question you might have is, what kind of sensors do we have in the car to make sure that it can think by itself, it can sense by itself, and it can act by itself? So here, what you see here, I gave you some examples of what are the sensors which are there on the car. So let's go on the top. So on the top, there is a camera, there's a smart camera. So there's a camera on the car which is generally used for checking the traffic lights and checking the lanes, because camera is a sensor which is very close to our human eyes, right? And most of the traffic signs, the lanes, they are meant to be interpreted by human eyes. So we have a smart camera which can detect lanes, which can detect traffic lights, which can even detect speed signals, construction sites alert, which can also sense pedestrians. Low speed maneuvers the camera can sense very well. For high speed and for long range, camera has a range of somewhere around 100 to 120 meters, by the way. Then we have one of the longest range sensor, which is the long range radar. Long range radar has a range of 250 to 300 meters. It is a sensor which can look the farthest and can sense velocity very much. So long range radar is really needed for your high speed scenarios, and making sure that, and long range radar so let's say if you have a car and you have a truck in front and a car in front. So camera can only see the truck in front, right? Because the car is hidden by the big truck in front. However, the radar can even look at the car in front of the truck, so it can see the objects or the targets which are even hidden for the camera or for the driver, which are just. Then we have a new portfolio added, which is a high resolution flash lidar. The reason you need a high resolution flash lidar is that there are certain scenarios where radar and cameras still do not work very well. For example, if you really want to have a good segmentation of the scenarios. And if you really want to do very highly autonomous driving, you really need to have very high imaging of the scenarios, and that cannot be done by a camera and a radar. For this, you would need a lidar. So we have a solid state flash lidar integrated in the car. That's the newest product which we have. In the back of the car, we also have a short range radar to look at the traffic which is coming behind you. Because as we all know, driving is not only looking forward, but also knowing what's coming in the back. If you want to change lanes, if you want to make a maneuver, you need to know what is coming at the back. If you want to make a full brake in front, you need to know, will someone crash for me in the back or not? Then we have a surround view fisheye cameras. These are the cameras they are 4 or 5 cameras, depends on the configuration of the customer, which are put all around the car to make sure that the car can look all around by itself. I'm not sure, did anybody of you had a chance to have a look? The Kia Seltos, the new Kia Seltos, which we have in the market, already has some sort of a surround view system all around it. So you can have a 360 view of the car sitting sitting on your seat. And of course, we need a very big processing unit. Processing unit is needed because, as you can imagine, we have very heavy AI algorithms, machine learning algorithms. They are very power hungry. They need strong processing power. So it's a small computer in front of the car, inside the car, to make everything happen. Okay, so I talked a lot, and one of the most talked about function which when I give talks is about emergency brake. And this is something which is very much relevant for India also. I always get a question, Anshu, what kind of situations we want to have and which an emergency brake should be activated? So generally, these are the 5 situations where we need to have emergency brake. You see, when the driver is intoxicated, he or she is under the influence of alcohol, or the driver is in a very panicky situation, whatever the case, it's not in the correct mindset to really drive. Then if the driver is very sleepy, so if he's not off, if you somehow are very cannot concentrate because you're just too tired on the road, driver is very distracted, or driver has already fallen asleep. And when this situation happens, the emergency brake kicks in. And how does it kicks in? I just show you a small video on that. So this is what we call an emergency brake assist, EBA. So as you can see, so you are driving your car, and so what happens is the car is always sensing with the sensors inside the traffic all around. So the car knows how the situation is, and you meet your friend, you see your friend or relative on the sides, and you say, hey, let's look around and say hi. You say hi, and the person responds, but you are not now concentrating on the road, so you're distracted. So what happens is, as you see from this line, so the car and the radar in the car is always watching the traffic and triggers a full brake for you. It either wants or makes a full brake in this case, because the speeds are too low, so you don't have time to warn now. This is a very standard feature now. It is rolled out worldwide. As I told you, there are now millions of cars which have this already. Good. Now, this was all about what we do at Continental. So, but one important point which I had a discussion with Manju and AP Singh sir was, what is in it for you? That's the most important question, right? What does Continental do? And what is the focus which we have on the people which makes it interesting about Continental Bangalore? So I just want to spend a couple of minutes to tell you about what Continental Bangalore is all about, what my business unit in Bangalore is all about. I just wanted to show you what are the expectations which we have from the people who are coming to us, and what are the opportunities which we provide to you. So let's start on the wheel from clockwise, right? People. So we have, at least I have tried to cover 5 aspects: people, skills, what culture do we have, what external connect do we do, and what are the global output which we give to our employees, the people. So right now, the ADAS team in Bangalore, the one which we are doing autonomous driving in my business unit. So my business unit has 12 departments. So each department has a department leader. So I'm department head for radar, and in all of our departments together, we have 1,600 people who are working on R&D. We have a team. I repeat, we have a team of 1,600 R&D engineers which work on autonomous driving and assisted driving solutions in India. And we are working for companies all over the world. So we are working with the top car companies in US, Europe, Japan, China, and now we have started some engagement with some companies in India also. So globally, we have 5,500 engineers spread over 8 countries. So just to give an impression, our business unit right now has a sales of somewhere around 10 billion euros. So it's a great revenue earner, and it's not only about number of people, but we also have we know that we are doing niche research. So at least in India, we really employ 15% of our workforce nearly is PhD. So they are doctorates, and we have also lots of MTechs and a few BTechs. And we have a very dedicated program for upskilling. So if you're a BTech, if you join Continental, we provide a path to engage with us. So we have dedicated MTech programs, we have dedicated PhD programs which you can upskill yourself. So because because the problem which we saw is when we have a young people like you joining us is you have really split between two problems. Should I do a job or should I do higher education? Why can't you do both? And we really want to give you the opportunity to do both together. Question is what kind of skills we look. So what kind of people are interesting for us? For us right now, the skills which we look in our teams, so in our colleagues, is we are mostly driven towards probability and statistical signal processing, because you need to have that statistical processing background to make sure this estimation algorithms, the Kalman filters you can implement. And you should be able to understand what's a probability density function. And because because your environment is very random, it's stochastic, so you have to understand how to model the environment correct. So I still remember here a lot of discussion which we have with Professor Shukla on mathematical modeling, so that really helps. And of course we are looking for people who have a strength towards digital signal processing and system design. So understanding how a system is made, some antennas, RF, low noise amplifiers, analog to digital converters, and filter design, and noise cancellation and stuff like this. So I am really thankful that Professor Thomas' course really helped me there. And most important, of course, one of the most important topic which we touch is estimation theory and information theory, for which is very important for us. As I already mentioned, Kalman trackers, minimum mean square estimators, maximum likelihood estimators. This is something which is bread and butter for us because we need to understand, reduce the noise, and track the targets. And of course, one of the important pillars on which we work is machine learning and AI. Here we are also very strong because we need to make sure not everything can be modeled. Something has to be, you have to make sure that there is, for example, very good classification problems. We rely on machine learning algorithms. And now there's a very clear trend to go more towards machine learning and AI so that we are much more future ready. Talking about culture and diversity, we have a very open culture. So I have been in the company, so this is my first and only company after my PhD. I've been 9 years here. It has never happened to me that someone has told me, aren't you go away, this is none of my problem, or why are you asking me? We have a very open culture because you can only innovate in an open culture. And we have a good diversity with respect to a male-female ratio, with respect to age, with respect to open ideas, from a fresh engineer to a senior management level, which is exciting for me at least. And I think that really brings that oomph factor, which makes it really much more fun to work. For sure, we know that we cannot innovate in isolation. Innovation should happen with discussion and with connection with external partners. So we really encourage our colleagues to have IEEE papers, give IEEE talk. As I mentioned already when the starting, I was as an invited talk at IEEE European Radar Conference in Paris last year. I gave a talk on automotive radar there in Automotive Radar Forum. So Automotive Forum, I was an invited talk for the radar, and we encourage this for everyone across. And we have university collaboration. We have active projects with IIT Delhi. We have active projects at IIT Madras or IIT Chennai. We have an active project with IIT Delhi, IIT Bangalore, and IISc Bangalore over different sensors. and we give you a proportion to have a global outlook. As I told you, we have my team. I can give you my example. I have a team in Yokohama. I have a team in Shanghai, in China. My biggest team is in Bangalore. That's why I live in Bangalore. I have a team in Romania. I have a team in China. Sorry, in Germany, Mexico, and US. So I have my team. I have my full distributed team in 7 countries. So we are a truly global team, and we really work together. And for me, this is the most interesting part of working in Continental, because I really get to know and understand different cultures. I get to meet and talk to different people, and we really encourage a good talent exchange between locations. So it's very common in our company to make sure that if you want, for example, tomorrow, if you want to go and work in China, or you want to work for some time in US, we make sure that it is possible, because it is important that we have a good exchange of ideas across locations. For us, in the end, the main goal is we want to develop talented employees who can steer and grow in these testing times. These times are very tough in all respect. COVID is really testing the automotive industry. And we want people who are smart, who are really goal driven, who want to grow themselves and want to steer the growth of our organization in these testing times. And at least I see it strongly resonating with our LNMIT motto, that excellence is our motto. And at least there I see excellence is, for example, for me, people excellence and Continental is also where I see the both vision of Continental India and our college LNMIT, combining together. Good. That is all from my side. I'm so sorry if it was a bit longer, but yeah, hopefully it was not that boring.
Yes, thank you, Anshu. So that was very informative, and I'm sure all of us have learned something new and a lot new about automotive driving. I have a few questions in the chat section. I'll take those. Before that, yes, there are few more coming. Before that, I'll ask my faculty colleagues if they have something to ask.
Anshu, one question. What are the frequency values you are dealing with?
Yeah, so in the past, sir, it was the automotive radar was in 2 domains, 77 and 23 gigahertz.
Okay,
But now
77. You are using 77. Good. Excellent.
right now, all the radars now are going to 77, because the chip manufacturers are pushing us to go in that direction.
Yeah.
So
That
right
is
now,
what I expected. Yeah, that's
yeah.
what I was
So
expecting. Yes. Okay.
yeah,
Good.
so it's 77 gigahertz with a bandwidth of 4 to 5 gigahertz. So that is the
Yeah.
biggest challenge now, to make a very high bandwidth radar and
Right.
less cost.
Yeah. Okay. Good. Thanks.
No problems.
Okay, so Kartike is asking that if something is coming from the behind, how does the car know? The car is stationary. Maybe it's not even powered on. So is there a mechanism that the car would come to know that something is speeding from the behind?
So if the car is not powered on, so then the sensors are not working. As simple as that. However,
Right.
one thing
Yes.
which we got a request from most of the Japanese car manufacturers is, I think you might have also seen it. When you stop the car and you switch off the engine, right, and then you open the door, imagine that there's a scooter coming from the behind. So then you will hit the scooter, right? Because you open the door and the scooter is behind and you might bump the scooter. So now what we do is, once the driver switches off the engine, still the sensors are working for at least 5 to 10 minutes, so that it will warn you that, okay, the scooter is coming from the behind, or a cyclist is coming from the behind. That feature is now being implemented. And as you can imagine, see, the battery has powered in the end. So if the use case wants, we can even keep it on for longer also.
Right. Thank you. So there are two questions from two different students, which are almost same. Like, when can we expect these on the Indian roads? And what will be the laws or regulations? Is there any plan by the government of India to regulate automated driven vehicles?
So the answer to the question, when we are on Indian roads, is 2 months ago. So, just if you do not know, please check MG Gloucester. MG Gloucester is the latest SUV from MG, which has a camera-based ADAS feature. It does not have it does not brake by itself, but it has a forward collision warning implemented, and it also has a lane change assist. However, we are in close touch, and I will just give you, if you have some time, I can also show you a video later on. We have driven a car with a radar on 20,000 kilometers of Indian roads, highways, city, gaon ka traffic, everywhere, and at least the results look very much optimistic. I tell you, when I started my career in autonomous driving, they said, "Oh no, it's only for Germany. It will not happen anywhere outside Germany." And then we started doing it for Italy because Italian traffic is so bad. Then they said, it only works for America and US, but Japan, the traffic is very congested. It will never work in Japan. Then they started working with Japan. Then they say it's only for first world countries. The developing countries is not there. Then it started working for Argentina, and it works for China. So it's not a question of if it'll come to India. The question is when it'll come to India. And as I see, when we are in this, I myself personally am in close discussion with Maruti Suzuki India Limited, Tata, and Hyundai. I'm very sure, give it 3 years, you will have a car with a radar on it on Indian road, which you can buy with the segment, not very expensive, with a span of 15 to 25 lakhs. That is gonna happen.
Okay, so there are two questions related to radar. So the
Yes.
first one is from Shubham. At 77 gigahertz, would it be possible to look through another vehicle which is made of metal?
No. So it is the skim depth is too low. You cannot look through a vehicle, but you see, this is the road and this is the vehicle, right? So this is you have tires, and there's a gap between the metal and the road. So you have a multi-path effect. And let me tell you, and the radar which we put on the car is very low. So we just put it below the number plate of the car. So a radar can look 3 to 4 vehicles in front also, because there's a propagation. There's a multipath effect, which is you get reflected from the tarmac road, which the radar picks up. So you don't look through it, but you look below it. Maybe it makes sense. I don't know. Is it
Now,
okay for?
yes.
Sorry, sir,
Yes.
to interrupt you.
Shubham.
Actually, my question was related to that the attenuation at such high frequencies is very high. That's why.
So the integration, right? What you meant?
No, sir. Attenuation.
Attenuation, yeah. So the attenuation in 77 gig is high. However, see, the point is, Shubham, I tell you, so the amount, so I cannot disclose how much power which we spit out, but let me tell you one thing. You have this beep beep car key with you, right? Car key
Yeah,
which
yes.
you clock and like beep beep, and the car goes close. So the amount of power which you use there and the amount of power which we use in the radar in one cycle is the same, even a bit lesser, to be honest. The radar uses. Yes, the attenuation is high, but the question is, we do beamforming. We do beamforming both in terms of range, Doppler, and angle. So you have range FFT, you have Doppler FFT, and you have angular FFT, which is the beamformer, by the way, to really reduce the noise and to push up the SNR. The reason is, Shubham, you have to understand one thing. We are talking about commercial radar, right? You cannot pump out high power because you will never get an approval for this. You have to get EMIC, the homologation, and even if you look at countries like Japan and Korea, especially Korea, because in South Korea, because they have a lot of military conflict with the North, so the amount of power that you can split out in a radar in South Korea is even 3 dB lower than in Germany. So we really have to find innovative solutions. And one of the innovative solutions which we have found is now the latest radar, which will pump out, which will produce from next year onwards, is a single chip radar. So I don't remember, Thomas, I think we talked about it extensively in one of our lectures when I was there. Entire RF and LF is on one single chip. It makes it super cheap. However, it has a huge issues in heating, but the cost is driving us in going in that direction.
It may be monolithic microwave integrated circuit, MMIC.
It is part of it is MMIC.
Yeah, it has to be.
It is an MMIC at 77 gigahertz, which you can buy for less than $10 a chip.
Yeah, I suppose, yeah.
So hope so, Shobham, I did answer your question, or?
Yes, sir. Yes, sir. Thank you so much.
No problems.
Right. So Sarang is asking, if we have rear view mirror or rear view cameras, why do we need radars on the
It's a
back
very good
side?
question. It's a very good question. It took me 2 months to understand the answer to that question. So there are two things. First of all, there's a very clear trend in the industry that the newest versions of the car, not only concept car, they are getting out. They're getting rid of rear view mirrors now. That's also one small, very strong trend in the industry which you see. However, having said that, the point is, we do not want to say that we're going to replace rear view mirror or we're going to replace how a driver drives. First of all, there's a blind spot. There's a blind spot. For example, the rear view mirror, so which you have on the side, and the one which you have on top of your head, if you look at the field of view of all three of them, there is a blind spot which is there which you cannot see in all three of them. If you don't believe me, just Google this on YouTube, you will find it out. That's point number one. Second part is, for sure, a driver is there to have a look at all the rear view mirrors and should make a conscious decision. We do not make the decision on behalf of the driver. If driver says in any point of time, by the way, I know the scenario better, he can override the system anytime, because we still believe driver knows better than the sensor. The sensors are there just to help the driver, so that sometimes you might miss to look in the rear view mirror. When I drive my car in a sit in Johari Bazaar, or or in that jail and Marg, I am like so scared because there's a traffic coming from all sides. It is sometimes overwhelming. So it is just to make sure that it can assist you while you're driving. Okay.
Right. So now there is a question that
Mm-hmm.
with all these upcoming technologies, we are surely going to new heights. But what about the accidents?
Mm-hmm.
Are they increasing or decreasing with these automated cars?
Mm-hmm. So
Is
if
there
you
any
look,
stats that?
yes. So the companies which keep the best statistics of accidents are not automotive companies; they're insurance companies. And the companies which really drive for this, because yeah, very simple, right? If you want to buy the new Tata Safari, Tata Safari's engine control unit was designed in Continental. We had to drive the new Tata Safari a lot, because how does your Bharat Accident Insurance knows what the insurance amount should Tata Safari should be? So we need to get the statistics. There is a very standard statistic, and what we see is, the answer to this question is not simple black and white. The answer to this question depends on region to region to region. If you see in a country like Germany or Europe or America, or for that matter Japan also, where you have a lot of penetration of assisted driving, there you see a strong trend that the accidents are reducing. Next time, whenever you want to buy a car, look for NCAP, so new car assessment program, NCAP rating. So that is the safety rating which you have on the car. It's like hotels from 1 to 5. 1, you don't want to get into the car, and 5 is the best you want to have, right? So there is a consortium of automotive companies and insurance companies which drives higher and higher regulation, so that the cars get safer and safer with time. Definitely cars are getting safer, and definitely you see that the casualties in the scenarios where you have significant amount of automation then are less. I don't have the statistics on me, but if you want, I can pull it out and I can share with you.
Right. So Aryan is having two questions.
Mhm.
One is like, is there any interest shown by the government of India towards automated cars in India?
Yes.
And
Mhm.
okay, so first we'll take one question.
Okay. So I can tell you, when I came to India back in 2016, one of my biggest challenge which I was handling was the 77 gigahertz band was not released for automotive driving in India then. So we really had a lot of discussion, a lot of, I would not say uphill battle, but some sort was not really fun. A lot of bureaucratic battles for 2 years, and now 77 gigahertz band is open for assisted driving or on Indian roads. And there's a very clear intent which you see from the government, because assisted driving also leads to fuel efficiency, and it's far more greener than the way a driver like me definitely drives. For sure, an experienced driver can do it better. So there's a very clear push from the government also. And one of the projects which we are doing with Triple IT Delhi also has some stake of government of India in there. And more than the government, the car manufacturers of India, the likes of Maruti Suzuki, Mahindra, Tata, they are showing very strong interest in there.
Right. So the second one is that Elon Musk said that expensive sensors like lidar, they are making these automated cars as expensive,
Mhm,
and they are making them out of reach of common people. Is it
mhm.
true? Do
That is
you
Mr.
agree with
Musk's
this?
opinion. So that's Mr.
Yeah.
Musk's opinion. However,
Right.
just want to get, we have to understand how what expensive is here. Okay, I want to ask uh, whoever asked the question. Just want to ask one question back. How much do you think a radar costs for a car? How much would you pay for a radar in a car? 1 lakh, 2 lakh? How much lakh do you think a radar would cost in a car?
I think I saw a video from the
Mhm.
Google, the Google automated car, and they said about one lidar costs about $10,000 or something like that.
LiDAR does cost more, but the question is the car. So just to let you know, so the Google uses our radar, by the way, and I know exactly because I was part of that project. I know exactly what LiDAR they use. I cannot name the company here, but the company which they are using, it's not a solid state LiDAR which they use. So there's a very so what we have done is we have bought a company in the Santa Barbara which has a solid state LiDAR system, and we have shrunk that cost by at least 6 to 7 times. I can tell you, Irene. And a radar on the perspective costs somewhere around less than $50. A radar costs less than $50. I repeat, a radar costs less than 4,000 rupees, including hardware cost, mechanical cost, R&D cost, everything. So yes, for sure, LiDAR is expensive, but assuming that
Can
autonomous driving is fully relies on LiDAR is also not correct. Sorry, Iron.
can
Yes, please go ahead.
can a radar replicate the same functions as a lidar? Like,
Yes.
can it do the same?
Yeah,
Oh.
so this is so just if you're interested, just Google on something called an imaging radar. So Professor Thoman can explain you far more than I can, but we have now launched a new imaging radar. See, Indian, what is lidar? Lidar gives you a point cloud, so a lot of small detections. If you have a radar with a very huge bandwidth, which if you put a bandwidth of somewhere around 10 to 15 gigahertz, you can also achieve the same thing because it's an FMCW radar. So higher bandwidth will gives much better resolution. Of course, you have to pay more on the processing power, but if you do that, your radar, an imaging radar, is still nearly one-fifth the price of a low-cost lidar. So there are possibilities. It's not that black and white.
One last question. That the lidar was not solid state, right? That Google used. It
No.
rotated 360 degrees to
Yes.
image the 360. So, like that also factors into that. That causes more wear and tear because it is a moving part, right?
Yes.
Uh,
So if you really
so
want
can
to know
you
what kind of, sorry, go ahead.
can you do it with a solid? Can you image the 360 environment with a solid state lidar with the same precision and with the same accuracy that you can do with the moving lidar?
Yeah. So the answer to the first question is check for the company called IBO. IBO was the company which was making their lidar for Google. Second thing is the answer is yes, you have a solid state radar and we develop it in Bangalore. So take a flight, come here, and I can show you in real time.
Okay. So,
Mhm.
Aryan, I hope you got the answers.
Yes, thank you.
Vaibhav is asking,
Thank you.
what are the processing boards or chips that are used in these kind of projects? Are there
Mhm.
some smaller custom built chips like which can work with Raspberry Pi or camera module, and we can make a smaller module to work as a college project, and later it can be scaled?
Very good question. So the answer is yes. Most of the times when we go out and make sensors, you have to imagine when Continental makes a sensor, we make in billions. So generally, we go into contract with the likes of Texas Instruments, Nvidia. We have a strategic collaboration with Nvidia. to make dedicated processing chips for us. However, if you want to do a college project, I can offer you two things. For sure, we do internships in Continental. So if you really want to learn an RN, if you really want to see how a LiDAR works, you can really spend, if you're ready to spend 6 to 8 months in an internship, you can come down to Bangalore to Continental with an internship. And by the way, it's a paid internship where you can really come and see and feel the technology. And same is also, I would say, if you really want to do for computer vision, right, with the Raspberry Pi or any other platform, it is possible, but I would really request you to really understand the, see, it's good to understand the technology, right? But technology, if it doesn't generate revenues for you, what generates revenue is how does this technology and who's going to buy it for what price. And if you really want to learn this, you can really come down there. We have a very strong internship program. You can really see how it's done. But definitely you can really make a very simple computer vision based system uh, on the Raspberry Pi, which we can do at least some things like lane detection or basic pedestrian detection should be possible. You just have to train the network with the right data, and data you can also find online on free source.
Right. So the next question is in the same line from Nikhil Paliwal. He is also an alumni. He is asking from an AI developer point of view, what are the tasks in the current industry that you are working on? Instant segmentation or some variations?
Yeah, good. So Nikhil, at least if you look at the trend right now, right, it's not only what Continental does. Most of the big automotives, right? If you talk about uh, Tesla, because Tesla uses our radar, so the latest Tesla also has our radar in it. So if you talk about Tesla or Uber, Uber also has our radar. Mercedes, BMW, and us and Bosch. We all big tasks are for sure is camera computer vision, where you have segmentation, classification, and you also have is and then second part is radar based, and this is the more trickier part where I think Professor Tomer can really explain in detail. Radar image is not as rich as a camera images. Radar gives you at best a point cloud, and at worst even bad invert at that. However, one thing which you can do is in radar tracking, you have a thing called association, where you have a lot of detection, you have to cluster them together. Here, what we are trying to do is we are trying to have new types of clustering algorithms for the problem of association. And also we are doing classification with using these AI algorithms in radar. And one of the most hot topic right now is fusion. How you put all the data together in one big network and ask it to fuse everything together. That is extremely challenging, and it's a problem. To be very honest, Nikhil, if you look at papers, you'll find papers after papers after papers on it. But the question is, what does those work on the real road or not? I give you an impression, right? When I make an algorithm, my team makes an algorithm, we check it over 1 million kilometers of on road, right? Because whatever we make, it's not that you can kill someone with that algorithm if it does not go bad. It's not that it hangs and you can restart your mobile app. If it hangs, someone dies at worst case. So that is tested. So what we need, what is really the need of the industry is we really have to check how roadworthy these algorithms are. And this is where it's a huge area, because a lot of AI topics are there, but how much AI topics are really roadworthy? How much I can really rely my life on, or someone who has designed, will it sit in the car with that algorithm running or not? If nobody can answer that question, I don't trust that algorithm, honestly.
So,
Right.
Nikhil here.
So,
So,
Yeah,
just
hi.
a
please.
yeah, hello, sir. So, I'm also doing my master's in Saarland University in Germany.
Ah,
Just started like this year, and now I'm in like my second semester. So, this question interests me. Like in Germany, it's like this is a good market, and for cars like Tesla is very popular here and all. So, just like you said. Like for testing and all, the machine learning and all are very data driven approaches. So is
yes.
data also like an part of the work which industries are working, like creating more reliable data, like which will work
Yeah.
for thousands of miles and all?
Yes. So this is, Nikhil, this is one of the biggest challenge which we automotive companies are facing as of now. Let's be very honest. Automotive companies have no experience in really working with big data. And this is something which automotive companies are pushed to now with this new autonomous driving coming in. So most of the companies, they find themselves flat-footed, and at least good thing with Continental that Continental had the vision to start early, and we have a very strong data. So right now, when we release a new product, we store somewhere around 6 to 7 petabyte of data of that, so that we can train algorithms on that. So that includes all your sensors: radar, camera, lidar, so on and so forth. So data is a strong part, and I think we are not as good as the Googles and the Amazons are, but hopefully we reach there, because that's what the market wants. Otherwise, you are out.
Right. So Sanjay was asking, if we make the cars fully automated, how
Mhm.
about the security? Will it be vulnerable to the hackers?
Very good question, Sanjay. Right now, in the past 3 years, there's a very strong push on cybersecurity and functional safe cybersecurity in the automotive domain. If you really want to know more about this, there is an ISO standard. I just tried ISO 26262. Just have a look at it, because right now every radar sensor or every sensor which we have, which we put in a car, has a lock, has a key, and it can only be accessed if you know that key, and that key is only shared with the dealer. So this is already, because we saw a lot of videos, right? That car got, someone from hacked the car and made it start or made it break or something like this. This is a very clear request which comes from all car manufacturers and the user themselves, that they have to be secured. And right now, all cars and all the data algorithms on the car, they are secured with the cybersecurity. And it's also a very, very hot topic. So if you really want to research, if you want to study that, I will strongly encourage. It's one of the most hottest topic right now in automotive industry.
So there was one question and I got disconnected. I partially remember that. And that was about, like, we see a lot of videos that the Tesla driver was asleep. Will these automated driving cars affect the driving nature, or are they going to help us, or are they going to make us more lazy?
The idea is to make us more productive so that we can use the time doing something else. But if you want to have a nap, then I think it's okay. However, that was on a lighter note, but on a serious note, as I told you, that there are different levels. There are different levels of automation. So I also write it down. There are different SAE level of automation. Uh, One thing is very clear if you look at the trend, that we will have cars in which will help us in some partial automation till 2025, and I am very hopeful by 2030 we will have fully autonomous driving, which means at some length, like for example on highways, you can really read your newspaper, or if you want, can really sleep. I will not say that it will make us lazy. I think it will make us safe, first of all, because safety is not only that you might injure yourself, but you can injure someone on the road. So there might be cyclists on the road. There are pedestrians on the road. I think it will make it more safer, and I am really hopeful that it will really release our stress, so that we can concentrate on other things than just driving.
Right. So Sarang has clarified the question I had misinterpreted. So he's asking, like, when the driver is asleep, is there any technology that will prevent from doing so?
Sorry, can you repeat, Sandeep, question?
Okay. Okay. Right. Right. Let me read it, the complete question. So there are videos which shows that the Tesla driver fell asleep due to less
Hmm.
engagement. Is there any technology to prevent this,
Yes.
or even
So
self-automated car are still not foolproof, especially for Indian roads?
this is independent of autonomous driving revolution, to be very honest. So there are already discussions which we have. So we call it in cabin sensing. What I mean by in cabin sensing is there might be a small infrared camera or a lidar or a radar which will check if the driver is sleeping or not, and if the driver is feeling drowsy, then it will raise a warning. So the main idea is that, let's say if you sleep if you're driving an autonomous car and if you're sleeping, so car will automatically park itself on a hard shoulder and wait for you to wake up, or try to make your buzzer to wake up, but it will not drive while you're sleeping.
Right. So Chinmay is another alumni, and he worked with me also. He want to connect with you sometime. And
Yes.
Chinmay, you can talk to Anshu directly.
Yes. So I think I can write my email address. That's also LNMI. Uh, so you can please read out to me.
And there is an interesting question that if the cube comes to India, what will be the estimated cost?
Oh, okay. No, if you really ask, so generally when people ask me a question on costing, I would say, what is the volume? The higher the volume, the lower the cost, right? However, but I think uh, cube coming to India, uh, it's a far fetched as of now. I don't think cube coming to India for the coming 10 to 12 years. However, one only opportunity which I see cube coming to India is if it's flying on some, for example, why not? If let's say, imagine our LMIT has a cube, so to take you up from that very very far away main gate to the hostel, especially when you had some beers and coming back. So I think I would really appreciate a cube picking me up there and dropping me to the hostel. Such application of cubes are there, but I don't think, but they are, as you can imagine, they're not very commercially viable options. I see that cube being coming again as a technology. I see in India coming assisted driving, so definitely collision warning, then some sort of emergency braking, ACC. That will happen in 3 to 5 years. Cube coming for the coming 10 to 12 years would be tough.
Sorry to jump in,
Right.
Anshu, but this is AP Singh here.
So
If the cube was to be used for LNMIT and to provide for people coming with too many beers, will there be a system in which it first zaps the guy a couple of times and wakes him up?
oh, that will be the that was the innovation which we have to do in LMIT ourselves. Yeah. So first it takes you to
Right.
the dean's office and then takes you to the hostel. And you cannot come out also then.
Okay, so last one or two questions. Anyone, everyone is welcome.
Anshu,
So
in India, certain roads are one way for certain times and dual on certain times.
yeah.
So all those things, your automated driving cars, those data has to be feeded, isn't it?
Yes. So sir, right now, what's the main aspect which we use is, first of all, we have connection to the maps, to the navigation data. So you have connection to the Google. So and Google would generally know that what is the traffic orientation there is. That is the current solution as of now. So which it will tell you, okay, between 9 to 6 it is one way, and after 6 to 4 it is two way, and then after 4 in the evening is again one way. That it knows from because Google Maps knows it because it is analyzing the data always. Uh,
Okay.
Second thing what we are trying to do is also is V2V and V2X, vehicle to vehicle communication and vehicle to infrastructure communication. So I was involved in my team was involved in the project, and we developed this first vehicle to infrastructure enabled car for Volkswagen last year. So what the idea, sir, is, imagine that you are driving and there's a car there's a car in front of you which knows that it's a one way. So, but instead of you getting the input from the Google Maps, the car can tell you, hey, by the way, be careful, there is a one way ahead. So this vehicle to vehicle information, V2V communication is clearly the trend, and which is a big part of autonomous driving. Second part is vehicle to infrastructure. So main idea is that there are some infrastructural points which some governments have set up, especially Singapore is really driving hard there, which are really communicating, broadcasting, by the way, the big inputs and the key criteria, the traffic information, the congestion information, and the one-way information, which again car does pick up. But then these are much a step forward. But as of now, we already have this information from Google Maps, from the navigation data.
Good. I
So
must say
I
that you have given a very Very, very nice
Sure, sir.
talk.
Thank you so
Your
much.
talk, yeah, and also your slides, very well made slides. And I think you had this desire in your mind long time back when you came, that
Yeah.
you want to give a very powerful talk, and I
Yes.
think you have
Thank you.
succeeded.
Thank you so much. Very kind of you, sir.
I,
Very kind of you.
I would like to add to that. Of course, we've been after Anshu to come. Of course, he was always motivated and he wanted to interact with all of us. But I think looking at his timetable, the way he's keeping busy, and I think we missed talking about two things which we should have told the audience. That he was the youngest in the history of electrical engineering department to receive the highest grade in doctorate program, and he is also the youngest in the organization to be promoted to the position of general manager. So these two really very relevant informations we missed to share with our audience. So yeah, and we really feel so proud of you, Anshu.
Thank you so much.
Yes, yes.
Great.
So, and we would like to see you sometimes on the campus.
Sure, ma'am.
Yeah, one more thing. Um, will it be possible, like you already mentioned in your talk, that your organization is, open for internships?
Yes.
So here we have a system of a semester-long internship for our students,
Hmm.
which they you do in their eighth semester.
Okay.
Eighth semester. Okay, so how do they go about doing it? Is there any procedure that they
Yes.
need to follow if they want
Yeah.
to apply for these internships? So could you just say something about that?
Yes. So we have a six. So as you can imagine, the algorithm which we're working on very complex. So we have a very clear criteria that we would like to have internships for more than 6 months, because generally we would prefer 8 months to 1 year. So ideally, someone who wants to have an MTech thesis can come here and do he or she can do their MTech thesis here.
Mm-hmm.
We have a paid internship, so though it's not a luxury amount, but I think it's a decent amount. You can really live around, and you
Mm-hmm.
can not go to a very expensive bar at least, but you can have a good time for sure in Bangalore.
Okay.
Second part is I can also then what I'll do is, ma'am, I sure. Sorry, sure, Sandeep, you were saying something? No,
No,
maybe I
no.
missed. Sorry. So one thing, and second part is what I can do with the Harival ma'am is I will ask one of my team members to give you the give. You can nominate someone. I can ask them to give you the details.
Mm-hmm.
We have this 6 months internship program. At least I would like, because generally we have. Ideally our request is 8 months to 1 year. Uh,
Okay.
and so that they can really contribute and they can understand. And for us, internship does not mean that for us we generally do not go to universities and hire. What our model is, let the
Mm-hmm.
guy person come, they should know us, they should like us, and we should like them. And 6 to 8 months is a good time, and then most of the times we offer a position.
All right. Okay. Okay, that's
Right.
very good. So
So
usually, I think it is done that way, right? Pre-placement offers are made, and then
yes.
if the company is happy with the students, then they convert it into a job offer, right?
Yes. So generally for us it's much more simpler, because it's not that we hire too many people every year. We just say okay,
Mhm.
because we are looking for people who are really more than technical skill. We are really looking at the orientation. So someone should
Okay.
be very technically oriented and should be very keen to learn and keen to perform. Everything else, I think, person can pick up. And most of the students are much smarter than I am, and I was for sure. So
Mhm.
here, if someone shows a very keen interest and motivation during the internship, we always give them an offer, because we are already invested 8 months, right? So they already
Right.
know us, they already know the
Mhm.
people, they know slightly the processes, the product a bit, because
Mhm.
the product is so complex. It takes nearly 1.5 years for someone to really get productive in the team, right?
All right.
Because someone really because again, if you make something, it is safety critical in the end. So one has to be very careful on what we releases on the road.
Okay. Okay, so that's good. I think our students have this opportunity to work with you, with your organization. So as you rightly pointed out, if you appoint somebody or if you give us the contact details, then we will
Yes.
initiate the process from our side. Okay.
That will do that, ma'am. Thank you.
Thank you.
Right, Anshu. So, okay. So, one last poll for anyone for the last question. We are already
Yeah.
11 minutes ahead of the schedule. Yes.
Hello, sir. Yeah,
Hi.
Nikhil again here. So, just following up on the part, is there opportunity in your German team to work on the sensor
Yeah.
fusion part? Like, and can I contact you somehow?
Yes, please drop me an email. We have also an internship program. You're in Salon, right?
Yeah.
So
Yes.
I think
Zalin.
closer Zalen,
Yes.
Salem, right? Yeah. Uh,
Yes.
so I think closer you might be to Ulm, right? We have a team in Ulm. Maybe we can think about there. There are some opportunities, Nikhil. I think I
Yeah.
reckon
Okay.
something should be possible. Yeah.
Yeah. So that was a very interesting presentation session. So thank you very much for that.
Hello.
I'll contact you soon.
Thank you so much, Nikhil.
Right. So, thank you, Anshu,
Thank you so much.
for being the part of this first interactive session with our alumni. And I'm sure everyone learned a lot. And it was not those typical boring talks. It was very
Oh,
interactive and immersive.
Yeah.
I leave the students to be the judge of that, but I just have to say one message to everyone. So I just really want to thank everyone and all the faculty, Thomas sir, APS sir, Dhariwal ma'am, Yogi sir, uh, for giving this opportunity and at least to helping me really groom up. And because I decided to go in microwave because I also did my BTech thesis with Thomas sir only. So I'm really thankful, and I hope some pearls of wisdom which I might have said maybe a link to you. Hope Please keep in touch. Be very proactive. Again, I tell you again, industry is not looking for Einsteins. Industry are not looking for people who can really solve the problem the fastest. We are really looking for people who are very entrepreneurial. We are looking for Elon Musk's and Steve Jobs, not Einstein and Newton's. So one thing is attitude really matters. So have that can-do attitude, which I think is there in our college, which helped me, and I'm very sure will help all of you. And if you think in any small way I can help, please let me know. I'll be more than happy to help you.
Thank you, Anshu. And we are only looking forward to the times getting back to normal so that we can have you on campus sometimes very soon. And that'll be great to see you in LNMIT.
Thank you. Thank you.
Yeah.
Okay.
Thank
Perfect.
you very much. Thank you, Anshu.
Thank
You
you.
Thank you.
really, you
Thank
really
you.
championed. You championed the learnability, funability, madability that we talk about. So those here who have suffered me, Nikhil included, will probably be able to connect with these three phrases. But you surely really demonstrated these three aspects. It is a great start to our webinar series. Thank you.
Thank you.
Thank you so much.
Thank you very much.
Have a nice
Bye.
weekend. Bye bye.
Bye.
All of you have a good time.
Nikhil, this is just for you. Please share your German phone number with me. You probably have
Yes, sir.
my number, so kindly send me a WhatsApp message. Send me your new mail ID also. And lovely to see you here and to see you participate and to connect with Anshu.
Yeah,
Thank you.
it was a good session. Thank you. I'll contact
Yeah,
you soon, sir.
great, lovely. Thank you so much.
Thank you.
As well.
Thank you, Sandeep sir, for coordinating and anchoring this lovely talk. It's been a great start to
No,
the
no, sir.
series, and we hope to see more of this.
Yeah. Yes, definitely we'll make it regular now. We are means little late in starting, but any start is a good start. So we'll keep it regular now.